As I mentioned at the end of the last video, we are introduced to hashing in our CCNA and CCNT studies, and we see passwords that are encrypted, that kind of thing. But of course, most of our attention is just not sending it in clear text and just trying to learn all these different techniques of, password hashing and then data hashing, that kind of thing. But we're not really concerned in our CCNA studies with how exactly that happens. And of course, that's fine, as I mentioned, because we had plenty enough to do in our CCNA studies without adding anything to it. But now we're going to raise that bar a bit. We're going to dig a little deeper and talk about what's actually going on with cryptography. Exactly what is it? Well, basically, and I do mean very basically, cryptography takes data as you and I and network intruders and basically human beings understand it and translates it into a data pattern that you and I and most human beings do not understand. And certainly that we don't understand immediately in some format that we would look at and say, hey, I have no idea what that is. Of course, once that data reaches its destination, the data has to be translated back to a format that everyone understands. And by that point, the main danger from a network intruder has passed, again, as far as that man-in-the-middle attack goes. We don't want anyone eavesdropping on the data, picking it off, and then just easily reading it. Now, of course, some cryptography processes are much stronger than others. Nothing is really perfect, and no cryptography is totally unbreakable, with one exception that we're going to talk about later in this video. And let me introduce you to an old friend of ours in the cryptography business. And I know you can't quite see the whole picture. I will scroll down a bit. This is an Enigma machine. And this is compliments of our friends out at Wikipedia. And I've just always been fascinated by these things. I was actually one of those kids who loved doing, code books and that kind of thing. Not Enigma level codes, but, playing with code books when you were a kid, and solving puzzles, that kind of thing. And the Wikipedia page here on the Enigma machine really is quite good. I know it's a little long, and you might want to skip some of the when it really describes the processes, but it really is quite an amazing machine. And even though the Allies in World War II were able to crack how these babies worked, several times more important advances in cracking those codes were actually made as a result of human error on the user's part rather than the machine having weak cryptography. There were certain settings that should be changed every single time the Enigma machine was used, and sometimes, the user just didn't do it. And that's one way that code breakers were able to break some of those messages with the Enigma machine. So cryptography's been around a long time, and it's likely that you participated in some kind of encryption slash unencryption process as a kid. It just depends on what generation you're from. I'm not from the decoder ring heyday back in the 30s, 40s, and 50s, certainly, but I definitely had a secret code book for a certain cartoon. And I'm sure most of the codes came out to be something like buy more Kellogg's cereal or something like that. Or maybe you wrote simple ciphers yourself, because a cipher is really, it's just a set of rules that we use to create an encrypted message or decrypt that message. And of course, the first cipher that you learn as a kid, is this top secret code where 1 equals A and 2 equals B and 3 equals C, that kind of thing. It's a substitution cipher, because that's just what you're doing. You are substituting one character for another. And as I do note, it is definitely not recommended for today's network. Substitution ciphers don't work too well. Now, transposition ciphers, what you're really just doing is shuffling letters around. Now, the bad part is that almost any shuffling is going to have some kind of pattern. So this isn't exactly the most secure cipher in town, even if you randomly place null characters or words in, because in some famous ciphers, and we'll actually talk about that in a moment, we suspect at this point that's what's happened with some ciphers over time that have just never been solved, is that they have so many null characters or null words in them that the pattern literally just can't be detected. Before we talk about that, what about that unbreakable encryption? There's something called a one-time pad that was actually originally developed in 1882. And the one-time pad has been proven to be mathematically impossible to crack if, and these are four big ifs, the key is random, is large or greater than the plain text, the key is never reused in whole or in part, and of course the toughest part of this whole thing, kept secret. So the one-time pad, definitely has its advantages, but it's not something you're really going to see in today's networks. Before we get into asymmetric versus symmetric, let me share something else with you here. It's a good article called 7 Codes You'll Never Break, and it is on wired.com. One in particular I wanted to share with you that I've seen, and here, we're not going to go through every one of these, certainly. The Beal ciphers, actually, we'll talk about for just a moment. This is actually from 1885, and it's supposed to reveal where treasure is buried in Bedford County, Virginia. The gold secret location, as it says, was allegedly provided by 3 cryptograms, one of which was already cracked. Unfortunately, the cracked code just told us what kind of treasure it was, and it doesn't say, hey, it is in, under this guy's house or whatever. And actually, Bedford County is not particularly far from where I live in Richmond, Virginia, but I have not gone up there to look for the gold yet. So if you look at this and you can figure out what's going on, I'll split it with you. So a couple of other interesting ones here. This is a famous one, Dorabella, that you might have seen a picture of before. I'd seen a picture of it, but I didn't know what it was until I read this particular article. And one particular macabre one in particular is the Zodiac Killer ciphers. And one of these was actually broken by a married couple that worked on it basically over the weekend. And literally, I mean that, over one weekend. And the FBI couldn't solve it, but they managed to. And that's great, but we still have like 1 or 2 of these that have never been solved. And one of them is supposed to say who he is. Now, whether that's actually true or not, I don't know. But again, you're looking at a substitution here, but as the article mentions, there are 340 characters made up of 63 symbols, but you don't know what they stand for. You don't know if they're letters of the alphabet or whether they stand for punctuation marks or anything like that. And even if you assumed that each symbol here represents just a letter, and nothing else, you know how many different combinations there are? However many this is. It's 26 to the 63rd power. And I think I don't even know how to put that into words, literally. So if you've got some time to spare, you could work on this cipher. Occasionally someone says they've solved it, and not to disparage any of their solutions, but it's usually like you start with what you kind of wanted it to say, and then you work backwards from there. Don't know if we'll ever see that one solved. And of course, Cryptos, I have actually seen this one, but I haven't worked on it. This is outside the CIA headquarters, I believe, in Langley, Virginia. See, all this stuff's in Virginia. We have nothing better to do with our time than sit around and come up with these unbreakable cryptography deals. And there's one section with 97 characters that hasn't been solved yet. And the person who created it is still alive, and he actually invites you to send that solution to him. So this stuff's been around for a long time. Again, that's an article you might want to check out there, on wired.com, called 7 Codes You'll Never Ever Break. And that is quite a challenge, but as again, some of them just have never been solved. Now, when it comes back to the encryption algorithms, there are 2 major classes of them, asymmetric and symmetric. And we know from our certification exam experience that anytime you see something like this, it's almost like TCP, UDP, right? You know this is going to come into your exam one way or the other. Symmetric, it uses one single key for both encryption and decryption. And of course, and by definition, the private part of a VPN, that's only going to take place if both ends possess that single key. Now, the really great things about symmetric algorithms is that they are much faster than asymmetric. Symmetric algorithms can run 500 to 1,000 times faster than asymmetric algorithms. Some of these you might have heard of. We're going to talk about them here for a few minutes as well. Symmetric algorithms include DES, triple DES, and I'm not making that up, it's actually triple DES, usually called 3 DES, AES, RC4, Blowfish, and IDEA, the International Data Encryption Algorithm. Now, asymmetric uses one key to encrypt the data and a separate key to decrypt the same data. And the key exchange is actually built into the operation of asymmetric algorithms. One key is going to be the public key, and the other is the private key. And I hate to insult your intelligence by telling you this, but the public key is available to the public, it's available to everybody, and the private key is not available to all. Now, that sounds fantastic, right? I mean, two keys are better than one, and you got a secret key in there, you got a private key, and this sounds fabulous. So you're just waiting for the other shoe to drop right now. And here's that shoe, my friends. Asymmetric algorithms are CPU hogs. I mean, not only do symmetric algorithms work much more quickly, but asymmetric algorithms, again, they are CPU hogs. Now, these particular algorithm types include Diffie-Hellman, RSA, and DSS, the Digital Signature Standard. Now, let me scroll up here just a bit. Hold on. We are actually going to pick up with this on the next video because we're going to go into a detailed discussion of VPN operation. And believe me, we have plenty of labs here, but there's some important theory for us to nail down. And before we do that, we are going to talk about two protocols that you see mentioned often in Cisco router options with iOS help, and that's RSA and Diffie-Hellman. So when we get to the next video, we'll take a look at those, and then we'll move on to a very detailed description of how VPNs work.